Welcome to Teachers. In this session, we will start with the first chapter of chemistry in class 10, chemical reactions and equations. Before we proceed, subscribe and make sure that you ring the bell button so that you will never miss any videos added. Now, chemical reactions and equations. Chemical reactions are the processes in which new substances with new properties are formed. Chemical reactions involve chemical changes. During chemical reactions, a rearrangement of atoms takes place between the reacting substances to form new substances having entirely different properties. Chemical reactions involve breaking of old chemical bonds which exist between the atoms of reacting substances and then making of new chemical bonds between rearranged atoms of new substances. During a chemical reactions, atoms of one element do not change into those of another element. Only a rearrangement of atoms takes place in a chemical reaction. We will now discuss reactants and products of a chemical reaction. The substances which take part in a chemical reaction are called reactants. The new substances produced as the result of chemical reaction are called products. In chemical reaction, reactants are transformed into products. The products thus formed have properties which are entirely different from those of the reactants. We will now give an example of a chemical reaction. Let us discuss a chemical reaction of magnesium with oxygen of air. When a magnesium ribbon is heated, it burns in air with a dazzling white flame to form a white powder called magnesium oxide. Actually, on heating, magnesium combines with oxygen present in air to form magnesium oxide. The burning of magnesium in air to form magnesium oxide is an example of a chemical reaction. In this chemical reaction, there are two reactants, magnesium and oxygen, but only one product, that is magnesium oxide. The properties of the product, magnesium oxide, are entirely different from those of the reactants, magnesium and oxygen. It is noted that chemical reactions can be carried out only in a science laboratory. A large number of chemical reactions keep on occurring in our daily life, like souring of milk when left at room temperature during summer, formation of curd from milk, cooking of food, digestion of food in our body, process of respiration, fermentation of grapes and other fruits, rusting of iron, that is when left exposed to humid atmosphere, burning of fuels like wood, coal, kerosene, petrol and LPG, burning of candle wax and ripening of fruits are all chemical changes which involve chemical reactions. In all these cases, the nature and identity of the initial substance changes because of the chemical reaction which takes place in it. An important question now arises. How do we come to know that a chemical reaction has taken place? This will become clear from the following discussion on the characteristics of chemical reactions. The characteristics of chemical reactions. In a chemical reaction, the substances known as reactants are converted into new substances called products. The conversion of reactants into product in a chemical reaction is often accompanied by some features which can be observed easily. The easily observable features or changes which takes place as a result of chemical reactions are known as characteristics of chemical reactions. The important characteristics of chemical reactions are evolution of a gas, formation of a precipitate, change in color, change in temperature, and change in state. Any of these general characteristics can tell us whether a chemical reaction has taken place or not. For example, if on mixing two substances, a gas is evolved, then we can say that a chemical reaction has taken place. We will now give examples to show all characteristics of chemical reactions one by one. Evolution of a gas. Some chemical reactions are characterized by the evolution of a gas. For example, when zinc granules react with dilute sulfuric acid, then the bubbles of hydrogen gas are produced. So the chemical reaction between zinc and dilute sulfuric acid is characterized by the evolution of hydrogen gas. Let us take another example of a chemical reaction in which a gas is involved. When dilute hydrochloric acid is poured over sodium carbonate, then carbon dioxide gas is evolved. So the chemical reaction between sodium carbonate and dilute hydrochloric acid is characterized by the evolution of carbon dioxide gas. Before we go further, we should know the meaning of the term precipitate. A precipitate is a solid product which separates out from the solution during a chemical reaction. Once again, a precipitate is a solid product which separates out from the solution during a chemical reaction. A precipitate can be formed by mixing aqueous solutions, that is water solutions of reactants, when one of the products is insoluble in water. A precipitate can also be formed by passing a gas into an aqueous solution of a substance, like passing carbon dioxide gas into lime water. Now, the second one, formation of a precipitate. Some chemical reactions are characterized by the formation of a precipitate. For example, when potassium iodide solution is added to a solution of lead nitrate, then a yellow precipitate of lead iodide is formed. Thus, the chemical reaction between potassium iodide and lead nitrate is characterized by the formation of a yellow precipitate of lead iodide. Let us take another example of a chemical reaction in which a precipitate is formed. When dilute sulfuric acid is added to barium chloride solution taken in a test tube, then a white precipitate of barium sulfate is formed. Thus, the chemical reaction between sulfuric acid and barium chloride solution is characterized by the formation of a white precipitate of barium sulfate. The third is change in color. Some chemical reactions are characterized by a change in color. For example, when citric acid reacts with potassium permanganate solution, then the purple solution of potassium permanganate disappears. It becomes colorless. So the chemical reaction between the citric acid and the purple colored potassium permanganate solution is characterized by a change in color from purple to colorless. Let us take another example of a chemical reaction in which a change in color takes place. When sulfur dioxide gas is passed through acidified potassium dichromate solution, then the orange color of the potassium dichromate solution changes to green. Thus, the chemical reaction between sulfur dioxide gas and acidified potassium dichromate solution is characterized by a change in color from orange to green. Before we go further, we should know why temperature changes in a chemical reaction. Chemical reactions often produce heat energy. When a chemical reaction produces heat energy, then the temperature of reaction mixtures rises or increases and it becomes hot. In some cases, however, chemical reactions absorb energy. When a chemical reaction absorbs heat energy, then the temperature of reaction mixture falls or decreases and it becomes cold. So when we talk of change in temperature in a chemical reaction, it can be rise in temperature or fall in temperature. Another point to be noted is that The compound calcium oxide is known by two common names, lime as well as quicklime, and the compound calcium hydroxide is known as slaked lime. Keeping these points in mind, we will now describe the change in temperature in chemical reactions. The fourth one is change in temperature. Some chemical reactions are characterized by a change in temperature. For example, when quicklime reacts with water, then slaked lime is formed and a lot of energy is produced. This heat raises the temperature, due to which the reaction mixture becomes hot. So we can see that the chemical reaction between quicklime and water to form slaked lime is characterized by a change in temperature, which is the rise in temperature. The reaction between quicklime and water to form slaked lime is an exothermic reaction, which means heat producing reaction. We have already discussed the chemical reaction between zinc granules and dilute sulfuric acid to produce hydrogen gas. If you touch the flask containing zinc granules and dilute sulfuric acid, it is found to be warm, which means that the temperature rises during the reaction. Thus, the chemical reaction between zinc granules and dilute sulfuric acid is also characterized by a change in temperature, which is a rise in temperature. The chemical reaction in which carbon burns in air to form carbon dioxide also releases a lot of heat. Now, another example of a chemical reaction in which heat energy is absorbed due to which the temperature falls. When barium hydroxide is added to ammonium chloride taken in a test tube and mixed with a glass rod, then barium chloride, ammonia and water are formed. A lot of heat energy is absorbed during this reaction, due to which the temperature of reaction mixture falls and the bottom of the test tube becomes very cold. There is a chemical reaction between barium hydroxide and ammonium hydroxide to form barium chloride, ammonia and water is characterized by a change in temperature, which is a fall in temperature here. Thus, it is an endothermic reaction, which means heat absorbing reaction. The fifth one, change in state. Some chemical reactions are characterized by a change in state. For example, when wax is burnt, then water and carbon dioxide are formed. Now, wax is a solid, water is a liquid, whereas carbon dioxide is a gas. This means that during the combustion of reaction of wax, the physical change from solid to liquid and gas. Thus, the combustion reaction of a candle wax is characterized by a change in state from solid to liquid and gas, because wax is a solid. Water formed by the combustion of wax is a liquid at room temperature, whereas carbon dioxide produced by the combustion of wax is a gas. There are some chemical reactions which can show more than one characteristics. For example, chemical reaction between zinc granules and dilute sulfuric acid shows two characteristics: evolution of a gas, that is hydrogen gas, and change in temperature, that is rise in temperature, as discussed. Similarly, the chemical reaction between potassium iodide solution and lead nitrate solution shows two characteristics: formation of a precipitate, that is a lead iodide precipitate, and change in color from colorless to yellow.